How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world, and today we're going to be classifying rational numbers. But before we start, if you haven't subscribed, please go ahead and consider subscribing, turn the notification bell on so you don't miss any future content. If you want to support the channel, linked in the description. If you haven't seen my other channel, MTV Alex, go ahead and do that and subscribe as well. Let's go ahead and get started. So, classifying rational numbers. So, for classifying rational numbers on here in 7th grade math, we only do so much. We're only going to be talking about rational numbers and everything, every category below that. So, this is something that we might already know how to do. And y'all are going to be helping me with this. So, first, on the first category, we're going to do this kind of like in a Venn diagram pattern. Let me do this a little bit thicker. So the first category that we're going to do, and we're going to do this kind of like in a Venn diagram pattern. So the first thing that we're going to have are going to be the what numbers?
Rational.
No. Natural numbers, right? So on those natural numbers, I need you to give me a few examples of natural numbers. 1, 2, 3, all the way to positive infinity. That's not an 8, that's an infinity sign. It's a little bit crooked, but it's an infinity sign. Now, after that, after the natural numbers, we're going to have the whole numbers. We're going to have the whole numbers. And in this, it's going to include all the natural numbers and zero. So you're going to have the naturals plus 0. So for example, you're gonna have 0, 1, 2, all the way to positive infinity. Now, after the whole numbers, and I'm about to sneeze, hold on. After the natural numbers, we have integers. So that, of course, is gonna include all the whole numbers plus the natural numbers, plus what else do we include in this category? We're gonna include all the negatives.
Yes, sir.
So for example, you can go from negative infinity all the way to positive infinity. So far so good, right? Very simple. However, after that, of course, then comes the rational numbers, which is going to include not everything else, but a lot.
Fractions, decimals, so much.
So right here, you have the rational numbers. And of course, it includes all the integers, plus the whole numbers, of course, plus the naturals. And also, it's going to include fractions, terminating decimals, and repeating decimals. And that's that. So a few examples over here, we can have, for example, negative 3.5. 0.3. You can have 5. You can have 1/2. Negative 1/3. So forth so on. As long as you're looking at the fraction, and that fraction, whenever you convert into a decimal, terminates or repeats, is going to be included as part of the rational numbers. Now, outside of that, you're going to have the irrational numbers, but we're not going to talk about those in 7th grade math. So the irrational numbers are going to be the decimals that never repeat. Like whenever you start dividing, the remainder is always going to be different, and the next decimal is going to be something different. So for example, something along the lines like 0.1578 3, 2, 1, 2, 7. I don't know. Keep on going. Whatever you want, but it never is gonna be. There's never gonna be a pattern. However, when I talk about over here as terminating decimals and repeating decimals, I'm gonna do a few examples over here. So, for example, terminating decimals. What is a terminating decimal, mister? Well, for example, if you have the fraction 1 divided by 2, when you do TiVo, 1 divided by 2, right? How many times does 2 go into 1?
2.
0.
0.
So you add a decimal and add a 0, bring the decimal up, and 2 goes into 10 5 times. 5 times 2 is 10, and when you subtract, you get 0. So this right here, that's a terminating decimal. That's an example of a terminating decimal. Now, on the other hand, a repeating decimal, what do you think that is?
One that never stops.
One that never stops and it's always going to be the same. And for that example, I'm going to give you 1/3. Can be positive or negative. It doesn't matter. Because when you do TiVo, get 1 inside, 3 outside. 3 doesn't go into 1, so you put a 0, decimal, 0, bring the decimal up. And 3 goes into 10 3 times. 3 times 3 is 9, and when you subtract, you get 1. So my remainder is not 0, so I have to keep on going. So I add another 0, bring it down, and I get 10. 3 goes into 10 3 times. 3 times 3 is 9. You subtract and you get 1. So if you notice, it keeps repeating. So you add another 0, bring it down, you get 0. Again, 3. And it's going to be a never-ending story. So that decimal, that division, is a repeating decimal. So this is an example of a repeating decimal. And you might see this like this, with a little line on top, or 0.33 because we like to round to hundreds. That's a repeating decimal. So that's going to be inside the rational numbers only. Now, you might have, and I can't recall an example of a repeating decimal, but whenever you're dividing, for example, you can get something like 0 point or 1 point, whatever. But the decimal is going to be like 34, 34, 34, 34, 34, and it never ends. So that's also a repeating decimal. However, it has a pattern, so we're just going to write this as like that. It means that the 3 and the 4 repeat over and over and over and over and over and over, forever and ever, for eternity. Any questions about that? Now let's fill this in a little bit. What if I have, let me do another color. The fraction 10 divided by 2. Where's that gonna go? If you're in my previous class, do not participate because you already know this.
Okay.
When does 10 over 2 go? Where would I put them? Rational, integers, whole number, or natural? Rational. So rational. That's it?
No.
What else? Huh? You said natural?
Yeah.
Why natural?
Because it's small.
No, look at the naturals. We have only 1, 2, 3, 4, 5, 6, 7, 8, all the way to positive infinity, right?
It's a whole number.
What is a whole number?
I think that's whole.
What do you mean? Why?
Like 1, 2, 3.
Stop guessing.
10 over 2 is a whole number?
No. Wait.
Integer?
Yeah.
Stop guessing.
Integer.
Oh.
Integers, I have positives and negatives. Now, let's look at this. Anytime you have an improper fraction, not right now. Every time we have an improper fraction, check if you can simplify that. In this case, 2 goes into 10 5 times. So now that is going to be what? Where does it go? This can be a natural number. It can also be a whole number. It can be an integer, and of course a rational. So that one fits in all the categories, right? Now what if you have negative 15 over 5? Rational? Can it be anything else?
Oh.
Whole number? Whole number is not negative, first of all.
Gosh. Rational.
Integer? Why integer?
It's negative.
Okay, but integers we have only positive and negatives. No fractions.
Oh. Then the rational.
Huh?
Rational.
Can we simplify? What will we get if we simplify?
3.
3, positive or negative?
Negative.
So this is the same thing as negative 3. So now where does that go? So that's an integer and rational only. So you gotta be paying attention to that. What about the number 4? What can that be? Natural, whole, what else? Integer, and so it can be all of them, right? What about negative 0.25? Integer. Let's look at the integers. What do we have on integers? Do we have any decimals in integers?
No.
No. So it's only going to be a rational number, right? What about negative 1/5?
Rational.
Rational. Can it be anything else?
No.
Nope. You can't simplify that.
What does national mean? National.
N, the N, the bottom one, the pink one, is natural.
It's natural.
So the natural numbers are going to be your counting numbers. So how do you start counting? If you go play hide and seek, how are you going to start counting? 1, 2, 3. You don't start from 0, right? You start from 1. So natural are your counting numbers. So any more examples that you want me to work? Tell me a number. Any number. Tell me a number.
20 over 10.
20 over 10. What is that going to be?
Rational.
First of all, is it a fraction or improper fraction?
Improper.
Improper. Can you simplify that?
Yes.
Do it. What are you going to get? 2 over 1, which is just 2. So that's going to be a what? Is it a natural number? Yes. Is it a whole number? Yes. Is it a rational number? Integer? It's all of them, right? One more number.
One more?
Yeah.
8 over 7.
21 over 10.
8 over 7 and 21 over 10. So this, first of all, improper fraction. How many times does 7 go into 8?
7 goes into 8.
Once.
One time. And the remainder is going to be 1/7. The remainder is going to be 1. The denominator is 7. So this is what? Is it a natural number? No. Is it a whole number?
It's an integer.
No. Is it an integer? Integer doesn't have any fractions. I have fractions right here. No. So it's only going to be rational. Now 21 over 10. How many 10 does 10 go into 21?
2.
2 times. And the remainder is going to be what?
So it's
1/10.
whole and 1/10.
So is it a natural number?
Yeah, no,
No. Whole number?
no,
Yeah.
Integer?
yes,
Integer?
no.
No.
Oh my God.
Rational number?
This,
Yes. So this is the same thing as 2.1. All right. So that is how you classify rational numbers. I really hope that you learned something today. If you did, give it a thumbs up. If you haven't, subscribe and turn the notification bell on. If you want to support the channel, there's a link down in the description. And go ahead and check out my other channel, MTV Alex. I do mountain bike stuff and DIY. Other than that, I hope that you learned something today. That is going to be it for this one. And then I'll see you on the next one. Goodbye.